With the success of Starship Flight Test 6, SpaceX has shifted focus to its next major milestone, Flight 7. Let's recap the key developments at Starbase over the past week. A day after the aborted Flight 6 booster catch attempt, Elon Musk clarified the reason behind the decision in a post on X. He explained that the communication link between the launch tower computer and the rocket was disrupted mid-flight, and this forced the flight director to forego the catch attempt. While the catch mechanism could have potentially succeeded, SpaceX determined that proceeding without reliable telemetry posed significant risks. A failure could have caused extensive structural damage to the launch pad infrastructure. So the team opted for a controlled splashdown of the booster in the Gulf of Mexico. The communication failure was traced to damage sustained by the tower's weather and communications antenna during liftoff. This antenna is critical for maintaining telemetry and control between the rocket and the ground systems. The intense acoustic energy and pressure waves generated by the Raptor engines during the rocket's ascent caused structural deformation and misalignment of the antenna, leading to the loss of communication. Post-flight, SpaceX teams promptly addressed the antenna damage. Engineers ascended the launch tower, assessed the hardware, and corrected its misalignment. It is expected that additional reinforcements will be added to secure the antenna in future launches. Apart from the damage to the antenna, it looks like the tower arms also encountered some issues during the launch. Immediately after the launch pad was reopened following Flight 6, SpaceX personnel were seen inspecting the arms and noting the damages. Over the following days, teams conducted detailed assessments and reinforced the arms to ensure their mechanical integrity. On Monday evening, the arms were raised to the top of the tower, and movement tests confirmed their readiness for upcoming missions. Another event during Flight 6 was a fire observed at the Starship's quick disconnect mechanism after liftoff. This likely occurred due to residual propellants igniting from the rocket's exhaust. Although the fire was extinguished after several minutes, such incidents highlight the importance of refining propellant handling and venting procedures to prevent recurrence. Teams are currently conducting minor upgrades and repairs to the launch pad infrastructure to ensure they are ready for Flight 7 testing. Scaffolding was installed around the top of the launch mount for detailed inspections. This step is part of routine post-flight evaluations aimed at identifying and addressing minor issues. The booster quick disconnect mechanisms underwent thorough inspections and repairs, followed by tests to ensure the system remains fully operational after the intense conditions of the launch. Booster 14, designated for this mission, is undergoing final preparations in the Megabay and will soon be transported to the launch site for static fire testing. Its counterpart, Starship 33, is simultaneously being prepared in Megabay 2 for its own static fire test. Ship 33 is the first Block 2 Starship prototype, featuring several design upgrades, including improved thermal protection, enhanced structural efficiency, and optimized aerodynamic surfaces. Flight 7 will serve as a critical test for these upgrades, providing SpaceX with valuable data to refine Starship's design for future missions. A recent NASA document filed with the FAA suggests that Starship Flight 7 could occur as early as January 11th. The document outlines NASA's plan to use its Gulfstream 5 aircraft, named NASA 5, to capture high-resolution footage of Starship 33's re-entry over the Indian Ocean. This observation will focus on critical events such as peak heating phases and splashdown, providing valuable insights into the spacecraft's re-entry performance. The Gulfstream 5's vantage point allows for capturing data that ground-based or orbital sensors might miss due to atmospheric interference or limited angles. This close-range documentation will yield critical information about the ship's thermal protection system, aerodynamic performance, and structural integrity during re-entry. By analyzing this data, engineers can refine the heat shield's design and verify material performance, ensuring improved performance in future missions. After analyzing the data they collected from all 6 test flights, SpaceX has identified the development of a fully reusable and robust heat shield as one of the primary technological challenges for Starship. So, it is essential for SpaceX to conduct steeper and more intense re-entry profiles in upcoming flight tests, and thoroughly document each moment to refine the heat tile design. Additionally, SpaceX is testing various heat shield materials in plasma jet chambers that simulate Martian atmospheric conditions. Data from these tests help engineers identify vulnerabilities such as chipping, cracking, or detachment caused by high-speed plasma flow. Apart from the heat tiles, SpaceX is also planning to implement metallic shielding, supplemented by ullage gas or liquid film cooling techniques, to ensure the ship will survive the intense re-entry heating and stresses. Metallic shielding involves using a high-temperature resistant metal as the primary layer to protect the spacecraft. They are less prone to cracking or chipping compared to fragile heat shield tiles. However, on its own, metallic shielding may struggle to dissipate the heat loads generated during re-entry without additional cooling mechanisms. So, in order to enhance the heat handling capacity of metallic shielding, SpaceX is exploring the ullage gas or liquid film cooling techniques. The ullage gas technique involves strategically venting the ullage gas from the propellant tanks to form a thin insulating layer between the hot plasma and the metallic surface of the ship. This layer of gas absorbs and carries away heat, preventing the metal from overheating. In liquid film cooling, they plan to inject a small amount of liquid propellant onto the metal surface during re-entry to form a thin protective film that evaporates when exposed to high temperatures. The phase change of the propellant absorbs significant heat, cooling the metallic surface. Compared to heat tiles, metallic shielding and active cooling offer many advantages, including the fact that they can handle multiple re-entries with minimal degradation. In addition, repairing a damaged metal panel is easier than replacing delicate heat tiles. However, metal is heavier than ceramic tiles, potentially impacting fuel efficiency, and designing and integrating gas or liquid cooling systems adds engineering challenges. Also, cooling systems must operate precisely to avoid overheating or running out of coolant. Ultimately, the aim is to identify the correct combination of materials and techniques to develop a fully reusable heat shield capable of surviving Earth's intense atmospheric re-entry and enabling missions to Mars. A day after Flight 6, SpaceX received promising news from the FAA regarding its future launch operations from Starbase. In a draft version of the revised environmental assessment regarding SpaceX's operations at Starbase, the FAA indicated that it will grant the company permission to increase the number of Starship launches from the current limit of 5 to 25 per year. The FAA determined that while there may be temporary adverse effects on certain ecosystems, particularly concerning endangered species and marine habitats, these impacts can be mitigated through compliance with existing regulations and ongoing consultations with environmental agencies. The agency concluded that the mitigation measures implemented during the 2022 environmental review are sufficient to support the proposed increase in launch activities. A public comment period on the draft report is open until January 17, after which the FAA will finalize its assessment. An increase to 25 launches per year would significantly enhance SpaceX's operational capacity, supporting missions such as NASA's Artemis program and other governmental objectives. Furthermore, SpaceX plans to transition to a larger, more powerful version of the Starship and Super Heavy rocket, referred to as Starship 3, which features substantial upgrades in thrust and performance. The draft report also includes provisions for launching these advanced variants from Starbase. This development follows a recent court ruling that dismissed an environmental group's request to halt SpaceX launches. The group alleged that SpaceX had violated environmental regulations by operating the water deluge system without the required permits. While the court acknowledged the lack of permits and imposed fines, it found no evidence of significant environmental harm caused by the system. SpaceX has since obtained the necessary permits, ensuring compliance and allowing uninterrupted launch operations. In parallel, discussions in Congress could reshape regulatory oversight for commercial space transportation. Representative Kevin Kiley has proposed legislation to transfer oversight responsibilities from the FAA to another body, potentially streamlining the regulatory process for companies like SpaceX.
That in fact has been endorsed by the FAA's own Commercial Space Transportation Advisory Committee, which unanimously recommended removing the Office of Commercial Space Transportation from the FAA, making it its own independent entity that reports directly to the Department of Transportation Secretary. This will remove a layer of bureaucracy that has proven to be very problematic when it comes to innovation in space.
This comes shortly after the FAA announced the creation of an aerospace rule-making committee aimed at refining licensing procedures, including the Part 450 regulations, to enable more frequent and predictable rocket launches. NASA has recently announced its decision to award lunar cargo delivery contracts to both Blue Origin and SpaceX, marking a pivotal advancement in the Artemis program. Under this agreement, SpaceX's Starship will transport a pressurized rover, currently being developed by the Japanese space agency JAXA, to the lunar surface as early as 2031 to support missions following Artemis 6. Meanwhile, Blue Origin's Blue Moon lander will deliver a lunar surface habitat by 2033. This initiative is part of NASA's broader strategy to collaborate with commercial partners to achieve its ambitious goals for the Artemis program. Leveraging the expertise and capabilities of companies like SpaceX and Blue Origin ensures that the program benefits from innovative and cost-effective solutions. In related developments, Lunar Outpost, one of 3 companies selected by NASA for the Lunar Terrain Vehicle program, announced its decision to use Starship as the delivery vehicle for its lunar rover, named Eagle. This rover will play a key role in Artemis missions, beginning with Artemis 5 towards the end of the decade. Now, let's get back to the updates from Starbase. The construction of the second launch pad is progressing swiftly at a launch site. The flame trench continues to take shape, with teams building the trench walls while excavation progresses to define its depth and structure. On the launch tower, teams continue setting up the drow work mechanism and its cable system, which connects to the tower arm carriage, enabling controlled movement of the arms up and down the tower. The orbital launch mount continues to take shape at the Sanchez site. Teams are currently finalizing the second layer of the launch mount, which will house 20 booster quick disconnect mechanisms. These mechanisms will supply high-pressure gases to the outer engine preburners, initiating the spin-up of the turbopumps before engine startup. Once the second layer is complete, the top layer will be assembled, which will feature the water deluge system. At the Sanchez site, the arms, carriage system, and ship quick disconnect have been undergoing refinements in preparation for their eventual installation on the tower. The tower is expected to be ready to receive the new chopsticks mechanism in the coming days. SpaceX recently scrapped Starship 26, the prototype that was fully stacked 2 years ago, and successfully completed cryogenic proof testing and static fire testing thereafter. Ship 26 was originally intended for a mission to demonstrate orbital refueling technology alongside Starship 27. However, after the common dome of Ship 27 imploded due to a pressure drop in the propellant tanks, the project was abandoned. Ship 27 was scrapped in July of last year, and just this past week, Ship 26 was moved to the high bay and dismantled as part of the scrapping process. It remains to be seen which future Starship prototypes will be selected for the orbital refueling demonstration that was originally planned for Ships 26 and 27. Meanwhile, debris from Starship 31 was recovered from the Indian Ocean and is now staged at Port of Exmouth in Australia. Following its splashdown during Flight 6, the vehicle broke into multiple sections, scattering debris across the ocean. Recovery teams, aided by vessels, gathered various components, including heat tiles, composite over-wrapped pressure vessels, and other parts of the spacecraft. These items are currently being prepared for shipment and are expected to arrive at Starbase for further analysis within the next month or so. Now, let's discuss the latest updates from the world of science and technology. Rocket Lab launched 2 Electron rockets within 24 hours, marking a record for the company and showcasing its growing capabilities in the small satellite launch market. The first mission took place on November 24 from Rocket Lab's Launch Complex 2 on Wallops Island, Virginia. This flight featured a suborbital version of the Electron rocket, known as the Hypersonic Accelerator Suborbital Test Electron, or HASTE. Specifically designed for hypersonic testing applications, HASTE provides reliable, high-cadence flight test opportunities needed to advance hypersonic and suborbital system technology development. Rocket Lab did not announce the mission in advance but later confirmed its success without disclosing any details about the payload. The primary customer for this mission is believed to be Leidos, a defense and technology company that signed a contract in 2023 for 4 HASTE launches. This launch marked the first operational flight of the HASTE vehicle since its debut in June 2023, and also the first launch from Launch Complex 2 since March. Just 22 hours after the HASTE mission, Rocket Lab conducted its second launch, named ICE-AIS Baby, on November 25, from Launch Complex 1 in New Zealand. This mission was part of a multi-launch agreement with the French company Kinéis, which is working to deploy a constellation of satellites for Internet of Things connectivity. Following liftoff, the Electron's upper stage successfully deployed all 5 satellites into a 643 km low polar orbit, inclined 97 degrees to the equator. With this deployment, Kinéis now has 15 satellites in orbit, advancing its goal of creating a 25-satellite constellation. Once complete, this system will provide global IoT connectivity in near real time. Applications include forest fire detection, water resource management, infrastructure monitoring, and logistics tracking. The constellation will enable communication with connected devices anywhere on Earth, enhancing efficiency across various industries. Rocket Lab previously launched Kinéis satellites in June and September, and has scheduled 2 more launches through the first quarter of 2025. Thank you for tuning in for the latest science news and Starship updates. If you enjoyed this video, please hit the like button, leave a comment, and share it with your friends. Also, don't forget to subscribe to the channel and turn on notifications so you never miss an episode.